is that interacting particles are beside each other and the energy moves from one particle to the next, but it does so in a sinusoidal way. So the displacement of each particle as it gets the energy will change with time. And the displacement of any particle at any particular time depends on the position the particle is away from the source, right? Because the source is gonna generate the energy is gonna move, it's gonna affect particles as it moves, and the displacement that any particle will have will depend on where it's located as well as the time that you're observing its motion, right? Now, with oscillations and with waves, as I mentioned to you, you can represent the displacement or the change in displacement with time as a using either sine or a cosine curve, right? Usually for oscillations you use the cosine curve, and usually for waves you would use the sine one, right? And the reason is, so as you can imagine, I'm going to go ahead and start share screening, but let me just let in Mr. Blake 1 second, who is all of 12 minutes too late. And let me record his name. I had the pen here. Okay, there we go. Mr. Blake, you're all of 12 minutes too late.
Miss, a friend of mine log in with their name, so I'm gonna step out for a bit and change that. It's Scott.
Pardon me?
My friend logged in with their account, Miss. So her name is displayed. So I'm gonna come back.
Okay, no problem. So are you seeing this screen where I have experiment 6 waves in a string?
Yes, please.
Okay, so this is what I really wanted to show you now though. Thank you for responding, Mr. Hodges. So basically, as I mentioned to you before, you would have been able to represent both of them with a sine or a cosine curve, right? The sine curve would generally start at 0 and it would vary continuously with time, right? And of course, as you can imagine, you'd have put your time on the x-axis, and your displacement. And I'm not going to write out the value, the word displacement, but this is what it will look like. That's how displacement will change with time, right? Now, for a cosine curve, remember the cosine curve starts at a maximum value, right? Similar in terms of the fact that it changes continuously with time. However, the change, and let's do displacement meter. However, it starts at a maximum value. Now, with oscillations, what would have happened is that you would have either compressed the body or you would have extended the body and then released and allowed it to oscillate. So it would have started off at some maximum value. With a wave, though, right? You would have it would have started off as a source. The source would have had no energy initially, and then it would start sending out the energy, and the energy would transfer. So the very first particle would have had, that's right beside the source, as the start time would have had no energy, and then the energy would increase with time. So that's why you would have the difference. Usually you would represent wave with the first one, which is the sine curve, and you would represent oscillations with the second one, which is the cosine curve. So in this case, you would have had y is equal to, and remember this is sine, this is some maximum value, which is gonna change with time, times sine of, and something as a function of time. And I'm not going to use omega, I'm gonna use something else to represent some term. Let's use some other, or let's use, no, let's not use phi. Let's use beta t, and then this one would have been a cosine, and let's use let's use gamma t, right? So then, as when initially at time t equals 0 for this one, right? Sine with beta times 0 is going to be 0 clearly. So sine of 0 would be 0, as you know, And so A times 0 would be 0. Again, that's why for this one, the sine would have started off with a 0 value and then increased to a maximum 90 degrees or pi over 2 radians later. With the cosine, you notice if gamma is if time is time equals gamma times 0 is going to be 0. So now 0 will start off with your maximum value. Usually in some textbooks, what you would find, so the top one would better represent the wave, where the energy starts off 0, increases with time, and moves on. Whereas the second one would be your oscillation, where you would have given it a maximum displacement and then let it go and allow it to oscillate. Right? In some textbooks, you will find that they use to represent the wave instead to represent the oscillation. And that's because with the oscillation, the displacement is usually in the direction of motion clearly, and that doesn't change with time. That changes with time, but it doesn't it's not a function of position because it's just one object. It's that one object that's just moving back and forth, right? Its displacement is changing. With the sine one, instead, they would have used y because they're considering that the vertical displacement is different from the horizontal position away from the object, not the object, the particle that will be oscillating that will get the energy. So a particle will get the energy. It will displace vertically. However, and it can displace horizontally depending on if it's like a longitudinal wave. But generally, it will displace in a plane that's slightly different from the its position plane, right? So as a result, usually you would find that for this particular one, they would have it as a function of horizontal position. So they would have written it as y is equal to Ka, and then you would have had, for instance, sine, then you would have had some Kx plus or minus omega t, right? Let me let in Mr. Swaby 1 second, please. 8:18, 2 more minutes before I cut off points. And I'm going to expand this view so that I can see you all. So I'm still not seeing Mr. Scott, Mr. Wisdom, Mr. Thomas, Mr. Blake, and Mr. Swaby. All right. So in this case, though, you would notice that as you move at a particular position away from the source, the displacement of that particle at that position will change with time. So that is why for the sine, it goes further to have where it's a function of the position away from the source in terms of the displacement, and the displacement is also a function of time, right? Whereas with an oscillating body, the displacement is simply a function of time because it's just one body. Whereas with the wave, it's a number of particles that will be affected, and they all have their particular position, right? So now that's going to be the difference. So before you did oscillation, I looked at the different tools of moving to the concept with energy transfer in a sense of. Now here's the extra nice thing of saving your medium. So we're not using water, or we're not with the air, we're not with string for a particular excess. So we're going to pause to apologize. I only got the information for you on Monday night, right? And immediately, luckily I was on the computer. So probably at that time I was on the computer, so I did my editing that format to and I sent it to. I realized you were able to information for Monday night. So hopefully, though, it was enough time for you to get information and do some amount of research so that you will move on nicely. Just in case we're going to talk about this particular exercise, again, it's on a string, right? Now, when you wave, and do not necessarily confine it within the medium, it's just allowed to move. What would happen the wave would travel? It is that you have a number in the same medium and you're traveling the same distance, and what's different is that the same phase different in I can't tell what constant, right? We have a constant for sure that velocity that they share, right? In that case, what would happen if they're traveling the same direction would superpose right along the length, and they would interfere in that a result, and then you will have one result and travel wave that would continue in the same direction as the original waves. If they're in different directions and they come to a point where they will interact, superposing that put that and continue along around its mirror wave, the energy will continue along in all its way. So the oil will have to stop that natural interaction with the body or the direction, they would interfere with the results that travels in the direction of the string. That will also have once you fix ends of the string, what happens is that waves, you will have waves which generate waves. And we're not talking about a pulse, because a pulse is a one-time wave and it dies and it's done, right? But if you generate continuously on this string and you fix the ends, what will happen is that when the waves reach the end, they will get reflected to travel in the opposite direction. Now, when you have waves that are traveling in the opposite direction that interfere with each other, you create a standing wave. So remember, if you're traveling in the same direction, then you create a wave that is just the opposite. But when you're traveling in the opposite direction, you have a standing. So let me go ahead and show you. Right? If it is that I have the only notice that it's in the way, and the next shows that I have done that you can estimate each other, and this notice that your energy is moving from your in this past example from left to right. I'm sure how this is in this way too, but me looking on my screen, I'm observing it moving from left. Remember actually this vision where wave A equals negative. If it's moving on the positive, then you use minus x minus negative. If wave is moving to x and it's plus negative, well, I'm not sure show you how to do it, but easily move. But if that increases, then the x must also increase if it's moving in x positive x direction. As a result, we maintain a constant the values have that as time is increasing, as x is increasing, and both times also increasing. So that's our relation, right? Like the normal question is that each particle will have about a particular position, right? So each particle will now have amplitude between which they'll move backward or on this. Then essentially no one being traveling from left to right. But then what is that the particle just move around. Each one will have its own amplitude, and you can see the particle that's wavelength or maybe there are some n/2 wavelengths away as well. Our direction and giving them a wavelength of same point away. Right? So when it came to initially before the fixing, no wave was traveling, right? The fix started traveling on them. Once the fix was traveling until eventually like pretty, then eventually you have once the superposition complete and interference is complete, you have the standing wave. Next to travel close source, right? But later on you will know that the standing wave. So that is what says the wave. The balloon was from how waves created and the wave or standing waves created on a string. So let's find out about that. Are we so far? And then on so go ahead and this exercise. So the way last string is in general, right? There are the properties of itself and the source, and it also depends on the properties of the source to transfer to itself. Also depends on the medium, right? So particularly we're going to be looking at the concept of the velocity. The velocity itself is dependent on, as I mentioned, the properties of transfer to the wave itself, and the velocity is also on the properties of the medium. So this is the relation. This is the way you have the unit of radiation, as I mentioned, with verbal. Say after radiation born, it's the right? The velocity is the velocity is not the displacement of the wave energy with time, right? It's not the vertical spinning particles as the end passes. This is the same displacement of the wave energy with induction. So it's a frequency of oscillations specified. Like we know how to determine what oscillation is. So exactly know this, but just because you forgot it is the level of oscillation. Now what actually vertical measure the wave. However, as a wave idea, you can take a ruler and just measure the wave and you already know what an oscillation is because you know what it is. Outside in the wave that you can get lost. The velocity function is equal to wavelength. So exactly the velocity wavelength and versus proportional. The velocity medium also a restricted force in the medium as well as the molecules, the number of molecules in the medium. For a string, you can bind it into a macroscopic scale and that is dependent because one is dependent on the mass. So then for a string, the velocity dependent on the tension or the word and what interest is what is with a string or any size, right? So the type of the string the velocity of that is in property of the string as well as property mass per next length. So the mass of the mass per length. So if I have 3 as a more length for a string, it means that one of that string has a mass of kilograms. That's all it means, right? So if you increase the tension on the string, the velocity will increase. However, so that means there is a positive relationship. The inverse upon right? Take note of positive versus negative, proportionality versus non-proportionality. The velocity is positive related to the tension, so the tension increases, the velocity increases. However, that positive relationship is not proportional. Therefore, the tension does not have an equivalent increase in velocity because it's not proportional. Instead, if you use quick increases, then you have a proportional increase in velocity. So therefore, that means that velocity is directly proportional to the square tension in the string. There is a relationship or an interrelationship between the velocity and the mass. There is a relationship between the velocity and the velocity. Increase the length, the velocity increases. However, if square length increases, the velocity will increase. The velocity is inversely proportional to the square of the mass of the string. Right? It is negatively related to the mass. If you increase mass, the velocity will reduce. If you decrease mass, the velocity will increase. Right? However, the inverse proportionality is a function of the square of the mass. Right? The country you are attending the gentleman is all fixed for only because you are consistently early, so there must have been a way to why you're late. Right, so where do you have any
Isn't it?
Yes, Mr. Artist.
As less increase, so with the velocity.
Yes, I said. And this is not increase.
if the square then
so there is a positive relationship in terms of the velocity. At the length velocity increases. However, if you want the proportionality, you would have to square the string, and then for each increase in the proportional increase in velocity. Yes? So, if you notice there is a velocity increase, however, if we're squaring it, then increase, you will increase in the velocity of the wave. Right? So that's here in some your in previous exercises, especially the one with the harmonic oscillation, you're looking at the period mass, right? And some of our talking about time was proportional to the mass. And you don't feel going further to say that period is proportional to the mass. But no, there is a relationship between your angular and mass. However, the proportionality lay with the square of the period. So, then it's not a negative. Initially, the difference between positive relationships. All right, so here, the velocity is very other than you can either calculate it. If you want that is a function of different terms, you can put the difference together. And this where you delete variables. So delete velocity was a function of frequency, is equal to frequency times variance. This is all dependent on the square root of the tension on the medium by mass unit. Then we get it equals to the equal the equal second of equal. It's equal to 0 equal, then we 10 plus 2. If you like on is equal, then the equation. So we then say all this is equal to independence of the medium, right? We're going to explore that today. Let's see what if we keep these properties constant, how does that affect the emotion? Remember, I mentioned before, this is a sharp condition. This is not an open wave. Open wave, it was a medium for the air means it's a wave that has been confined on a string that is on both and on a taut GHT, right? A taut string on the same, which is fixed. But the first event is also just do this with the we're going to keep the properties constant, change the properties of the medium, right? And then in the second exercise, the second exercise, you know that the properties of the medium and set the properties of social and the properties of the subject mental behavior, right? The body having to fail in the topics, you want to have sat down in text or five and with enough. So if you want to promote to care use of explanation, you know, so we can just start this and say, because sometimes you not necessarily evaluation is very learning. Here's our sex assessment, right? Similar to creative standing with. This is a passive, right? One, you have the job, right? This one, it cause it religion, right? And that is the on all hands, have so they have a massive activity, right? This is supposed to be. There should be some or any working carefully, right? It should hold this operate in as a effort. It does also you need to at home. If I don't just add them as something else, work with challenge. Or mass or the way to put it in the high force that you will request with this in all of the sure. The force of the weight or the force of gravity acting on mass to the string as a force. So they will then they don't expect will then the same way, right? They will pretend the directions of the incoming waves as a rule. They will information to create a standing wave, right? Like this. We're asking to see up to their specific position, right? So this is what will happen first. The first situation where you set it up, you have the string, the mass of the string, as well as the length of the string. From that, you will be able to determine the mass per unit length of the string, right? So mass divided by the length, the mass of the string divided by its length will have given you unit length. Now, luckily, that equation is already provided, so they will give you the mass, giving the length of the string, or let's just divide the mass per unit length, right? You want to assume that this is the true, right? So in those exercise, once you get that information, right? So it will have, when you have this where you have the string, put the open mass weight. Then with the vector, so you would have selected the oscillation you want, the velocity, and it will go ahead and generate the wave. Then you have a standard wave. From that, now your mass that you attach, so that you will be able to measure the wave. And remember, in order to measure the wavelength, you would have used like a ruler, and you would have then video the length of one oscillation, or you measure the half oscillation and multiply that by 2. That would be the length. So then for each one, you would know how to the wavelength. Remember, the string is moving. That means that the two forces that create the string will be equal and opposite. To have the string, it would have a tension force within it that's opposing the force that is added to it, which would have been the mass weight, or the weight of the masses. So then if you know the weight of the mass, then you know the tension in the string. Because the string is in linear equilibrium, which means that the forces on it must be equal to 0 newton. The two forces on it, the force of the string, which is the tension, as well as the force of gravity, which is the masses that are added to it. So that means that the two forces are opposite. Just make it understand. Here is the string, the force that's being attached, the tension, and here's the force of gravity that will now be created on the string plate, right? So this is this mass times gravity. So this is the two forces, not 0 newtons, because this is linear equilibrium, so 0 newtons will be equal to T, and the force of gravity, this will be minus G, right? So therefore T equals mg, right? So you know that times gravity, you will know what is the tension is. And so then if you have that F like equal to the square root of, and I'm changing from T and use FT instead, because I want you to get this up with it. I change it from now, this will be the force. And you can figure this energy, which is my acceleration due to gravity is 9.8 meters per second squared. If you want to use 9.8 meters per second squared, then if you want to go for that, use 9.8 meters per second squared, because that engineer you want to get room, then certain, but some may say you should be more specific. But because we know it varies right around, we know where this experiment was conducted, so we can go ahead and use the 9.8 meters per second squared. Then, you know the calculation and so and know you will also do the wavelength. First, you're going to do this for 6 months. For the first month, you will measure and record it. And 5 chances. That means for 6 months you will have a sweet weekend. You can calculate the based on what I just showed you. The next month you have the state industry as well as wavelength. So based on this equation, where your frequency times the wavelength, your potential of the last few, you're keeping the frequency. Two variables changing with wavelength and the depending on mass. Mass unit cannot change because it's shaping off anything of it. And you can string bounce it out. So therefore mass is not changing or anything. The only way it's gonna change is if you start off or try to make it more narrow, or you try more way to increase and beef it up. So the mass will change. So therefore, how much as waiting and then I can about how we will be able to calculate mass per unit, right? And all that therefore is this way, such as it falls into the same equation of motion. Sorry, the same graphic for a straight line, right? Why? Because not doing things and the frequency it will require in this exercise, right? In the procedure is that it's key present. So then the auto that will be changing will be the matter of attention and the unit, right? So when you think that very want to evaluation but best illustration you're then you will transform emission so we have in a straight line but you can actually have values, right? So what and all these are doing this that won't have any confusion what is the way of course and basically one of the requests has to be fully allocated. So here it is. You have F lambda, remember we're doing it looking at this before, and it's equal to or straight line doing is equal to the square of the constant times 0 plus constant. This is to show the relationship between this variable, this variable, etc. That is the x is in here. That's one. I call it that. Right? And this is not more like this is the relationship. Why you can use this very much faster than this also action shape one not right? So here we're already doing something like that. We'll clear up the first thing we clear is that we clean the number here is equal to ft over and that equal to n. Then nice pt. And we're mastery then share you. Right? So now we can apply the of the course. For example, the constant is not other constant. It has and it carries on and that way can see. To put the mu, let's say the mu. If it is with lambda square versus the tension, okay, you will say the tension is in there, which are the way change that what is there. So you may say the lambda square y-axis, which will need down over mu square. And in this case, I'm going to use 1 square. I will sit on the box is to the right. So versus mass gravity, and the drawn is over mu. S the key gravity here is drawn to right. That's option 2. One option so far. Option number 3, we will say I will tell on like between 10 and 6 that means that you may like it, right? Then what will happen is that then you will have mu as your base and lambda square, right?
Is in the tension.
Remember, because they are variables, right? They can go on either y or x. So usually you find the dependent one. And guess what? That's what the is. So you get flexibility. I call my y-axis, my y-axis for the independent, and I call my x-axis the dependent variable. Which then allows me to put my independence on the y and on the x. It's a matter of how I get the information. It's like in the same thing, and it's how I evaluate. It's always basically the same thing, but how I evaluate. Over G and then option. Here experiment to consider tension and one consider wavelength. Easier to only option 1 and 3. Right? You want to do another. If you choose to use the traditional way of putting your independent variable on the x-axis, then you will clearly put your tension there, which then means that your the inverse of f squared. Now, it's still the number one, but it says you must say wavelength for hertz. Right? If the absolute error from the line is playing, so you have no difference, right? And because of the tension, but the frequency can get the readings of the graph, rearrange to make new subjects, and then you get a unit. This mass per unit then is your experimental value. Your experimental value, you will using percentage rate, right? So you get your mass tension, and then you will also have the wavelength. The table that you originally you have automation that you need in order to produce this graph. So if you're collecting mass information, you're going to have a graph that has 10 units that those values must be in your table. We are doing two different tables, provide one table that's associated information for one graph, right? So we're going to make sure that so far you have a calculation that performed to create the graph, and then you're going to generate the graph, and then your calculation graph to produce the mass per unit, which you compare to true one using percentage rate error. So because that when you base your calculate error in so you're going to use error rate to error rate in your calculated using error creation. So you're not going to start information in a logical. You have your data, right? As well as whatever you perform on the in your table. Then you're going to calculation for your data. Then you are going to produce a graph and information on it, and then you're going to do some columns using the graph and those graphs, right? So either your table, your graph, you're putting information that flows kind of easily forward. Now the first exercise, there's a second exercise where in this case here, they're changing the here, all of these are the same, right? And all of which will be the cause of the source for the change of the weights. So I keep the and the very place as here, where this constant very frequent is here the shock. So they change the free of the source and the look of this about 6 about 6 elements here in this case 6 points in which your wavelengths were generated. Here we are seeing this table where fields wavelength and the constant is used having properties to the constant to normal and the error of measure which drawing the same plus or minus. So in this case, frequency, so now you have cells of it which you will not present, right? So you must have a table with all the relevant information, right, that you're going to use to produce the graph. And they're going to show the calculations that you're doing to get that information to produce the graph. And they're going to show the graph that which would have no relationship between wavelength and frequency. And you're going to also
Can I repeat that?
oh, you're talking that
What did from the
between frequency and wavelength, right? because in the history that's changed and then the changes in accordance. They want to show that the relation from graph and you have to from that mass per unit. But this is your second value to per unit, which you're going to compare to using percentage of it. So you have two vertical reading masses and bottom acid wavelength. It's something about you difference acid change wavelengths. All of I don't put error calculations together in the mass unit value that you get as well as compare them to the true values in percentage rate error. And then final into is show your second. It's your answer. You expected and then the demonstrated what you know that is with however, they are with a portion of which number of patients in the list is explaining and discussing. And reason why it's called equation is the patient is the key is these by constant and all that is suitably vary, then they should relate to each other is what the patient is. See how you discuss. I have to have expectation between hydrogen authorities and what would I was like to write out these devices and then think about but now you have started out the journey of thinking about finish just like what you request to see how that impacted your ability to better result. If you have used this in such a way, say every way with stories of what you have and demonstrate. Do you know your side when there is something there, it's really if it is a tool value to you, then to work to make sure equipment is functioning, have two values to you, how can you give you two values and then you are using and not that big pressure has been for use. Right? And you compare both to each other, whether it's using percentage or somehow comparative equation, and then you know how the equipment provides how experiment. As I remember that your comparison, but you know to look back at I don't better than 2%. You need to individually what could suggest that support as well. It suggests certain numbers that you have to things that you and lead have some savings or features.
One person to have a great room and go in
great for
you click on the graphic. What's the other thing is
So what if we want like split
You've been extremely quiet this morning. Are you still here? Let me see if I can get more